So as a summary for the irreversible trimolecular-type third-order reactions, so first we have A plus B plus D forming into products. So trimolecular siya because we only consider A, B, and D. So our reaction rate for negative DCA equation is equals to KCACBCD. And then we looked for the relationship of CA, CB, and CD, and that is through the BCA table. And then we got this equation. So this is the equation to be used when your equation or the chemical reaction is like this. And then if CDO is very much greater than CAO and CBO, therefore your reaction would be a second order because CDO at any given time in the reaction is just equals to CD. I mean, CD is at any time of the reaction is equals to CD. Gamay lang kayo ang iyahang changes. So, it would be considered as a second order reaction. So, and next, we have a special case 1. So, if we have this type of chemical reaction, A plus 2B forming to R. So our working equation would be this, or the rate of reaction equation for for A. And then we get this equation. And then this one is only valid if M is not equal to 2. So what if M is equal to 2? So the ratio between CBO over CAO is equal to 2. Therefore, at any given time, the ratio of CB to CA is equal to 2. So we have CB is equal to 2CA. So we now have a relationship between CB and CA, so we just have to directly substitute that to our rate equation, which was earlier this one, CA, CB squared. So substitute lang ang CB. So we have this, and then we just used separation of variables, and we get this equation. And then special case number 2, what if A plus B forming to R, but still a third order siya overall. So it doesn't mean na pag walay coefficient dire-diretso na kag second order, kay 1 plus 1 is equal to 2, no. There are cases like this na A is first order, and then B is second order. So we have that. So overall, we have a third order. So your working equation is this CACB squared. And then after integration, at first finding the relationship between CB and CA, we have these two equations. So one is by CBO through the concentration of CBO, and then another is through the concentration of CA and CAO. So we have these two equations, and this is when M is not equals to 1. Then what if M is equals to 1? Same happen, CBO over CAO is equals to 1. So therefore, at any given time in the reaction, CB over CA is equals to 1, or CB is equals to CA. Therefore, if this is our rate equation, we just have to substitute CA here for CB because again they are equal, so we have CA raised to cube, and then we have this equation. So these are all the equations you use for irreversible trimolecular type third order reactions with this type of chemical reactions involved.